This is 10 for the algebra of matrices. So we're going to take what we learned last lesson and then apply that with a little bit of mixture of algebra 1. So the matrices, whatever size it is, matrix A and matrix B are equal if they have the same dimensions. So that's very important to realize. They have to have the same dimensions. And we talked about that earlier. So here's an example 1 of you have a matrix ABCD, so matrix right here, and you have a matrix here. Notice they're the same size, a 2 by 2 matrix, and equals another 2 by 2 matrix. And therefore, if that's the same size, then you know this corresponds with that. So A equals 1, and then B equals 3, C equals 5, D equals 2. So you can make that connection between that if they're the same size. So that way you can compare the matrices. So we have different orders of operations and mathematical things that we normally apply to normal equations or numbers and stuff, but with matrices you got to pay attention. They're slightly different. So the sum difference and scalar product of matrices. So you could take two matrices and add them together. Again, the sum of A plus B is the certain matrix size n plus n. They have to be the same size, and then you literally just add entries. So the corresponding entries of A and B matrices, then you just add the corresponding matrices. We're going to do an example of that. The same thing with the difference. If they're the same size, you add the corresponding entries. Scalar product is literally you take a scalar number. Scalar is just like a constant number, and then you multiply it by each entry of the matrix A. All right, and we're going to look at some examples here. So here's, for example, four matrices, A, B, C, D, and then so if I wanted to take A plus B. Well, notice this size A and size B, so this is a 3 by 2 matrix, and size B, or matrix B is also a 3 times 2, 3 by 2, so they're the same size. Now I can add them together. So you're going to take each entry and add those guys together. So A plus B, I'm just going to take each entry, so I'm going to take this entry, I'm going to add it to that entry. So that would be 3. And then take this entry with that entry, that would be negative 3. And then 7 plus 2, that would be 9. And then the same thing with the next row, so negative 3 plus 0 would be negative 3. 5 plus 1 would be 6. And then negative 1/2 plus 2 is 1.5. That would be the matrix. And notice it's still the same size, 3 by 2 matrix. Okay, so A plus B. And you do the same thing with C minus D. Again, if they're the same size, we can add each entry together. So this is a 2 by 3 matrix. This is also a 2 by 3 matrix. So yes, we just subtract the two entries, each entry of C minus D, and that's how you do that. C plus A. So if you tried C plus A, notice they're not the same dimension, so you cannot add these, okay? You cannot add C plus A because they're not the same dimension. And then 5 times A, this is the illustration I was talking about. You're basically taking A, and you're going to multiply each entry. So it literally looks like this. So here's 5, and there's A. So here's 207, and then negative 3, 5, negative 1/2. So you're basically going to multiply everything, each entry on the inside by 5. So that would be 10, that would be 0, 35, negative 15, 25, and then negative 5/2. So again, that's 5 times the A. So how do you solve a matrix equation? So, well, you literally, if I ask you to do this right here, so you're going to take 2 times x, so that would 2x minus the A equals the B. So I'm going to take literally each one. So I have, 2 times the x, which that's what I'm trying to find. I want to know what this matrix is. So 2 times some matrix, then minus the A matrix equals the B matrix. So let's fill in what I do know. It's easier, you can fill it in right now, or it's easier if you do the algebra part first. So if I had 2x equals A plus B, or A plus B divided by 2, or if you think of it this way, x equals 1/2 of A plus B. So I'm going to add matrix A and B together. So I'm going to add these, and they are the same size. So I'm going to literally just add each entry together. So that'd be 6, -4, 2, and 4. But then I'm going to take 1/2 of that. So matrix X, that's what that stands for. There's literally half of each one of those. So 3, -2, 1, and 2. So we literally found matrix X because we just used algebra first, and then we just did the operations that it's calling for. All right, so matrix multiplication is a little bit more complex. So it even says it's more difficult to describe than other operations. So the product AB of two matrices is defined when the number of columns is equal to the number of rows. So that you need to really pay attention to. So here if I have M times N and N times K, so as long as those match, then you can multiply them. Okay, so literally the columns has to match the rows of A to B. Right, so they have to do that before you can multiply them. So notice here I have A and B, and I have a 2 by 2 matrix here, and here I have a 2 by 2, and the columns has to match the rows, which they do. All right, so then once I do that, then I'm going to literally calculate A, B, and then B, A. Now normally, I want to say this right off the very beginning, you're saying, well, aren't they the same? Because normally, like, if I had 2 times 3, isn't that the same as 3 times 2? Well, with normal numbers, yes it is, but not with matrices. So the way you're going to actually multiply these, you're going to take, I have the A, let's do this first, so AB. So I'm going to write these 5, -3, 7, 0. I'm going to write it right next to, that's the A, and this is the B, 1, 9, 2, -1. The way that you're going to do matrix multiplication, you first have to recognize what size of matrix you will end up with. Well, remember I told you before you can even multiply matrices, these have to match. The columns have to match the rows. And now the end result, the end size of the matrix will literally be this times this. So in this illustration, everything's a 2, so it's kind of not the best illustration to start with, but I wanted to make it simple, and a 2 by 2 is a very simple illustration to show this with. So I know my end result here will be a 2 by 2 matrix. So I'm literally going to have space here, space there, space here, space here as my final answer. Now the way to get each of those spaces, what I'm going to do is I'm going to take this 5, I'm going to multiply it by the 1, and then I'm going to take 7 times the 9, so row by column, and then I'm going to literally add those together. So it's literally, to go in this first spot, I'm going to take 5 times 1 plus 7 times 9. So you might want to pause the video and make sure you understand what, again, I'm taking the red times the red, the blue times the blue, and I'm adding those together, and that result will go in that first space. Then I'm going to stay with that same row. Again, I'm taking this row, row 1, and I'm multiplying it by column 1. And then I'm going to take row 1, and then next step, I'm going to take it by column 2. So you're going to have 5 times 2 plus 7 times -1. Again, pause the video, make sure you understand what I'm doing. I'm taking row 1 times column 1, and then row 1 times column 2. This is my new row 1. And then the same thing is I'm going to go back, and I'm going to do the exact same thing with -3. So I'm going to take -3 times, I'm going to take this row now, times column 1 and column 2. So -3 times 1, add that to 0 times 9. And then again, I'm going to do the same thing. Take this row and multiply it by this column. So -3 times 2, and I'm going to add that to 0 times -1. So again, the resulting matrix, that's 5 plus 63, that would be 68. -3, and then plus 0, that would be -3. 10 plus -7, that would be 3. And then negative 6 plus 0, that'd be negative 6. So that is AB, okay? When I multiply AB, I get that. And you would do the exact same thing if I multiplied B times A. So B times A. So once I do B times A, you're going to end up with negative 148, 7, and then 63. Again, you might want to pause the video, multiply B times A, and see if you get those numbers. But the whole reason I wanted to show you this problem, because one, I want to show you how to multiply matrices, but secondly, I wanted to show you that AB is not the same thing as BA. Not when you're multiplying matrices. So let me just close and just emphasize, when you multiply matrices, so if I had like a 2 times 3 matrix, a 2 by 3 matrix, and I wanted to multiply that size matrix, by a 3 times 5 matrix or something like that. Well, notice again, these have to match, okay? The column and the rows have to match. So the column of this has to match the row of this, and then if they do, then the resulting matrix will be 2 times 5 matrix. Okay, so I automatically know I'm going to have a 2 by 5 matrix. And that's very important to know, because then I'm looking for, 2 rows with 5 entries. Okay, so and then once you do that, once you know that, what size you're going to end up with, then you can start the process of going through, doing the row times the column, adding them together of each entry to find the matrix. Again, that's product. Finding the matrices of the product of them, and then we also talked about scalar multiplication and adding and subtracting of matrices. Remember, when you're adding and subtract matrices, they have to be the same size. When you're multiplying matrices, you got to look at the column and the rows, make sure they match. These have to match, and then again, the resulting dimension will be those outside numbers, the rows and the columns.